Good to go?
Good to go.
Let's freaking go. Privacy is not what you think it is. We hear a lot of times people talk about how blockchains aren't private and how we need more privacy features in blockchains, but there are really different things to think about here. There are legal concepts of privacy, there are moral or economic choices made by protocols, and there are also tech limitations. In this video, I'm going to break down what privacy means in blockchains and in Web2 in general to you, and also show you the developments in each of those different areas and what you can expect for blockchain privacy in the coming years. So talking about privacy. Privacy is really like an umbrella term. It can mean a lot of things. It can mean information about you that you don't want other people to know. It can mean specific regulations such as the GDPR in Europe that deal with private data. In an economic context, information that leads to people taking actions to gain profit or make someone have losses. So a lot of different things can happen within privacy. And the main breakdowns that we do are on those three areas. So there's a legal concept of privacy, which is where do people have a right to privacy? Like in GDPR and other like legal bodies, there are actually regulations in which companies and people have to keep information about other companies and other people private. They cannot disclose them, and there could be a fine or some sort of penalty for whoever disclosed the information. So this is one kind of privacy. And this is the privacy that was in game when we were talking about Tornado Cash. Tornado Cash had a technology to make transactions private on Ethereum, especially not really the transaction itself, but the owner and the recipient of the transaction could be made private. And the app had to be taken down by the US government after they found it to be involved in different money laundering schemes. There are different opinions on whether this is a correct legal decision or not, but the fact is this is a legal discussion about privacy. So Tornado Cash, whenever you think about privacy in the context of Tornado Cash, you can think there's a very important legal component here, like what is a legal way to have privacy. And this is one of the ways in which you can talk about privacy. A different way is in a moral way. Instead of talking about like what the regulation requires us to do regarding privacy, you can talk about what is the correct way to deal with people and like entity data. Going back to Tornado Cash use case, we can talk about blockchains here a lot. Like blockchains are by default totally public. You can see everyone's balances, you can see all the transactions, you can see the actual people behind the accounts, but through the different like interactions, you can actually like guess that, like through social media and like Discord interactions and different stuff, you can actually begin to understand who people are. And that leads to a lot of problems, both morally and practically. You can have security problems for people that could be like kidnapped, that could be like hacked, and at the same time, it's a moral. Many people in the community, especially on the cypherpunk side of the digital community, see privacy as a fundamental value that they have to uphold. So they have to uphold people's privacy because that's what they believe the right thing to be. So this is a different way to talk about privacy. It's like talking about an ideal world of privacy. What is the privacy that you consider to be like morally necessary, like an ethical thing? And there's another way to talk about privacy, which is on an economic idea. So talk about economics, we usually talk about information asymmetry. So there are things that I know that you guys don't know, and vice versa. And those things that I know can have an economic value. Let's say that I know that someone's going to be dumping some token, like 20% of the supply in the next 3 hours. Me knowing that information is going to change the price in the market because I'm going to sell before them. And this problem happens a lot in blockchain too, especially in the context of MEV, minor or maximum extractable value. People can actually gain insight into other people's actions before they actually are committed into the blockchain through the mempool and through other tools. And that allows them to leak information and profit off of that information, causing a social cost. This is yet another way to talk about privacy. So privacy is not a single thing. Privacy is a lot of different ways in which information being shared between people can cause some sort of damage or some sort of profit to someone. It can be a financial one, it can be a moral one, it can be a legal one. It could even have more different acceptance of the term. So this is what privacy is as a general. It's a very broad term, and we shouldn't really use the term privacy as an umbrella term when we're talking about it online because it just makes everything more confused. I have come up with a definition of privacy that is more technical that I'm going to share with you guys so that you can actually understand what privacy is in a more fundamental and logical level. I'm just going to draw something here so that I can think about it. So when you think about all those instances in which we use the word privacy, they have one thing in common. They're always talking about situations in which information that is about someone or something is learned by other people. And from that, you can actually generalize a formula that shows us what privacy is in a very technical way. This is going to be using like logical notation. It should be familiar to people that are into computer science or like hard sciences in general, but I'm also going to explain everything so that you understand the idea behind this concept. So basically you have to understand some ideas. You're going to have E here that's going to represent a person, like any person or any entity. You're going to have a question, so a question could be like, how old are you? Or like, what's your name? So that's a question about someone in the system, question that has an answer to it. And I is the answer to that question. So if someone asks me how old I am, I'm going to say 26. But like, if I should say that or not is a different question. And A is an extractor algorithm. What's the idea of an extractor algorithm? That's some piece of code, some system that you're going to be able to use to figure out an answer to some question I. So let's say if I'm trying to learn someone's birthday inside of Facebook, I can use an algorithm that goes into their page and checks their birth date, and from that I find it out. So if there's any way to learn that information, I can use it. A different example that's more counterintuitive, I want to know if I have an account in a specific website. What they can try to do is they can try to create a new account with my email, and if it says something like this email has already been used, then they know that I have an account in there. Even though the site's not exactly saying that to you, there is an algorithm that you can use to learn the information. So that's what A here means, some algorithm that is able to learn the information. And then we go to predicates. So a predicate is kind of a formula. Let's say we should call this P. This is the privacy predicate. Here is where we're going to be encoding the logic we're just talking about, like legal logic, let's say GDPR. Like, there's a logic about privacy, like who should be able to learn each information and who should not. Like, on GDPR, you can't use your customers' information for anything that you haven't told them about, and you can't share that information without their consent. So we could translate that into a lot of logical sentences like this. Is X, which X would be a person or entity, allowed to learn answer to question Y? So this could be asked about any system. So I can ask like, in GDPR, can I, as a supplier of a tech company, learn the current payment status of all their customers? Based on GDPR, I could say that I could not. But based on a different legislation, I could say that I can, if it's different. Based on moral values, it depends on who you're asking. If their moral values include a high value on privacy, they're probably going to say you cannot. But if they actually don't value that much, they think it could help the company learn if they're going to be able to pay their bills, maybe they could accept it. So the idea is you can implement any kind of logical reasoning about what is privacy, and you can encode this into a lot of those sentences. Is a specific person allowed to learn a specific information? And you're just going to say yes or no to all those questions, and this constitutes a definition of privacy. So this idea, privacy is a definition, and this is a more practical idea. Regardless of the definition of privacy, this means like this EXYZ means can X, so entity X, extract information about Y with an algorithm Z? So this is a different question. Notice that in some cases, like the example I just gave you about the website, could be that the website enforces a lot of privacy rules and they don't want anyone that's not inside of their administration to learn anything about their customers. They don't want them to know their emails, they don't want them to know their names. If you ask them like, am I allowed to learn like someone else's email from website XYZ? The answer of P would be no. But as I just showed to you, if I think about the algorithm, I could just do an algorithm that goes there and tries to create an account with that person's email. So if I trying to learn the email using the algorithm that I just mentioned, can I learn the information? The answer will be yes. So this would be a no for P and a yes for E. And basically the whole idea of privacy, like how can you implement privacy in a system? Very informally, you're going to be implementing privacy in a system if those two are never different. So whenever someone is allowed to learn information, there should be a way for them to find the information using this formula. So there is a way for them to apply an algorithm A and learn the information. And if I say that someone should not learn information, that shouldn't exist any algorithm Z that would make this true. So like if I'm saying, no, you as an external person cannot learn the emails of anyone that has an account on this website, then the algorithm I just explained to you, trying to go there and create an account, shouldn't work. They should just say something like this: an email has been sent to confirm your account. And they would always send that regardless of whether there is an account on that email or not, so you cannot learn if the person already has an account. That would be a way to block that. So this is like the world of ideas. What's the idea? Like, what's the ideal word for your app? Like, what people can learn, what information, and this is the real world. Like, what can you actually learn using algorithms, using different techniques, using cryptography to actually extract data that was supposed to be private inside your application. And the way to actually write this in a logical way would be this formula here. So this means like for every value of x and for every value of y. So regardless of the person that is asking the question and the question that's being asked, for any question that's being asked, if P for that pair x and y is true, then there should be an algorithm z that supplies this question, that actually allows the person to withdraw the data. And if the answer to P, x, y, so if the system says you cannot learn that information, then there shouldn't exist any algorithm z capable of extracting it. This is the basic idea. If you don't want someone to learn some information that's in your system, then there should be a way for you to block that from happening using technology. And this is what I consider the definition of technical privacy. Technical privacy is when you can do this. Like, if you're able to do this inside of your system, then it's private. There's a whole article where I explain this, I'm going to link that below, but this is the kind of the overall logical idea. And you have a lot of systems today that they are private. Like, the idea that they're trying to implement in privacy, they actually do. Sometimes they have a problem that you don't consider their ideas of privacy to be correct. Let's say Facebook, they have privacy terms, you might not agree with them, but they're trying to follow this logic to the best. And they are trying, like investing a lot of money to try to not allow any algorithm to extract information that shouldn't be extractable. And they actually fulfill this. So when you have a problem with Facebook, you don't have a problem with technical privacy. You have a problem with their definition of privacy, which is P. When we talk about blockchains, it's the other way around. Like, everyone thinks privacy is a nice feature because of moral values and because of practical security concerns. Like, everyone thinks privacy is important. But the problem is not that you don't want people to learn information. The problem is that there are algorithms that can extract this information because the network's public. So they are different privacy problems. I'm going to give you some more examples in a minute. But overall, the idea is there is a policy question here. How do we influence and make companies and systems have privacy definitions that we actually agree with and are good for society? This is one thing. And the other thing is, how do we create technology that allows us to have any possible kind of privacy ideas and implement them? Because today it's impossible to have a totally private blockchain yet. It doesn't work. It's impossible to have an app like Facebook that doesn't share its data with the company itself. There's no possible way to do it. So there are two different concerns. How do we build those privacy systems, and what concept of privacy do you use to define them? The reason we talk about blockchain having a privacy problem is because the architecture, like the way they're designed, makes it very hard for us to avoid people from learning information. So the problem is not on the P side. So we have a concept of privacy. We want people to not be able to see your balance, to see how much money you have, to see who you're transacting with. So this is kind of a consensus in blockchains. But at the same time, the way that tech works doesn't allow that to happen. And the problem here is there are a lot of ways to extract that information. I'm going to show you guys how we do this in two networks, in Bitcoin and on Ethereum. They both have this problem. And it all starts with the idea that blockchains are replicated state machines. That means we have a lot of different nodes, like different places, that have to agree on something. That something is a ledger. It's this all transactions in history, the current blockchain. And for them to agree on that, they have to have some formula to check if everything is correct. And how do they do it? They have to run the computation multiple times. So I, as a person, send a transaction here. So let's say I'm 0x1. I want to send 1 Bitcoin to 0x2. When this is included in a block, everyone's able to see that I sent 1 Bitcoin to this address. And this node is able to see it, it puts it in a block, and it broadcasts to every other node. So everyone now has to agree that this happened. And the only way for people to agree that this happened is to actually run a computation on all the historical data and check that all transactions in the past led to you having a balance of at least 1, so that you can actually transfer that to 0x2. So the way that everything works together makes sure that everyone learns all the information about the system. And if you try to omit, you don't want to say who sent the money, then how can you be sure that that person had the money in the first place? How can they possibly learn that? And if you don't want to show who the money was sent to, then how can that person receive it? How can the person claim it? And if you don't want to show that someone transferred an amount of money, how can you possibly be able to show that you're not violating some kind of condition of the system? Like, let's say you're creating new money, a lot of new coins. So those are all problems that made it impossible for blockchains to be private. They chose an easier path that allowed them to be built, which is pseudonymity. It is like having private accounts because no one knows who owns the account. It's just a bunch of numbers. But those accounts are not private themselves. Like everyone can see what they are doing. They just don't know who owns them. So this is the fundamental problem in blockchains. If we assume that our privacy predicate is no one should know how much money I have, no one should know who I transact with, and no one should know which kinds of tokens I own, which kinds of people I interact with, then the blockchain doesn't work because there is an algorithm A that can extract this data. You just have to pull all the historical data and match everything that 0x1 did, and you can find out stuff about it. Especially if you use your wallets to connect to social applications. Like if you go to a social network, if you take part in airdrops, if you do QIC, anything like that, it's gonna link the address to your physical person, and anyone that's looking at the ledger can see all that you've been doing. And that can be even worse, because if you interact with, let's say, a grocery store near your house, a physician, or like, I don't know, any kind of person that everyone else knows who the person is, you can start to draw a social graph. You can see that you're connected to people in a certain region, so they know you live there. They can see you have paid a surgeon, they know you have health issues. And this can go on for a lot of stuff. Anything you put in the blockchain is going to be dumped into a social graph that anyone can see. So this is kind of the fundamental problem with Bitcoin. And when we go over to Ethereum, it's the same problem in a new way. Because now we have smart contracts. So instead of just sending money, as I did here, I can have an account, like let's say I have a smart contract here, that is an auction. So I want to bid 10 ETH on some asset, on some NFT or some piece of real estate. I don't know, I'm bidding 10 ETH. In the moment that I bid it, everyone knows that I bid it. So I can't have a private auction because everyone can see it. It's the same problem. For you to execute the code of the smart contract, you have to send it to a node, it broadcasts to the whole network, and everyone sees what you did. You have to transfer the money here to make it lock away. So basically, there's no way to execute any private logic in here. You can't like have private stuff going on. You can have a vote, like a real vote for a nation's election. You can't see who has voted for whom, like you can't have people prove who they voted for. So this doesn't work. To be honest, when you think about smart contracts, they have a lot of possibilities, but most things in the world require some sort of privacy. Most social networks, most like web services, most like real life services, they aren't just like showing all the information about everything to everyone. Like a store isn't gonna show you how much they paid for some merchandise. They aren't gonna show you how much tax they're paying, how much they pay the employees. And this is kind of crucial to actually be able to sell your value. And here it's impossible to do that because you can all see everything. And this applies to any kind of computation. So the problem in here is that if you get a P here, so a P that is, people shouldn't know all this information I just talked about. So a different person shouldn't know my account balance, a different person shouldn't know what I'm doing in the smart contract, then this equation does not hold because there is always some sort of algorithm that is able to extract this data below. So this doesn't work. Neither for Bitcoin nor for Ethereum. It simply doesn't work. There's no way for you to not have this information leaked. There have been technology developed to help like alleviate this, like Tornado Cash and others, but they are able to only hide some part of the information. There is no way to actually like be able to shut this closed and only have people know what they are transacting, no one else knowing anything, like it is with Web2. There's no way to do this in Web3 nowadays, and I believe this is one of the main challenges for the future. If we want to get mass adoption, this is going to have to happen sometime. And this part is important because I often hear this phrase, like, Web3 is not private, we still need Web2. Like, it's good to have a Web2 experience inside of Web3 to have privacy and better UX. And that's just bullshit. This is not a valid argument, and I'm going to show you guys why. In Web2, we have the client-server architecture, which means a company has a server, This can be like many machines, it can be an AWS or anything, but it's still a server, still like a centralized machine that has all the data and does all the computation. And you as a person have your PC or phone, you communicate with that and you get data back and forth. All the data is in the server and the company always has access to the server. Like using the Facebook example again, if you're transacting your data with Facebook, you're liking posts, you're writing things about yourself, you're gonna send it over to Facebook and it's going to allow some people to read it based on them having an account, and some information is not going to be shared, it's going to be kept inside of here, but it's still inside of Facebook's dominion. They can use it for their own means as a corporation. Like they can use it to train AI models, they can use it to drop profiles on you, they can use it to anything basically. And even if they can't use it in a legal way, your data is still leaked to them in an information way. If you think about the privacy predicate again, let's say GDPR says PXY that you should not use this data to train AI models without the consent of your users. But there is still an algorithm that is able to take the data. Like anyone that works at Facebook can just go there and query the data and use it for something. You're probably never gonna know. And this is the point. Like, this is also not ideal. Like, the Web2 architecture doesn't support any current way for you to actually have data that the company has no way of accessing. It doesn't support a way to actually protect user data and prove to the user that the data is being kept private from everyone, including the company. And this is the problem that Web3 is solving. Like, Web3 already solved a part of it. They solved the part where you can prove what you're doing with the computations. Like, in smart contract, you have a system that works exactly as stated, cannot be changed, and is run by the blockchain, not by a single person. So you can prove that it's a legitimate software. So this part has been done. It doesn't have private state yet, but like this is even worse. It doesn't have any kind of guarantee that your data and your information is being computed in the right way, and they also have access to all the data that's generated from it for that whole eternity and can use it for anything, and you can't prevent it. So this is why Web2 also has a privacy problem, and Web3 is actually solving that. If we're able to solve the way in which Web3 protects data and actually create a way to stop people from learning information on the blockchain while running it in a trustless, decentralized manner, you can actually have a better way to do Web2, because you can do everything that Web2 does in a really private and really verifiable way inside of blockchains. So this is the overall vision. Like, Web2 is not better than Web3 in terms of privacy. It is, I wouldn't say it's worse, but it's a different architecture that has different trade-offs, but both of them aren't able to make data totally private and not allow anyone to access it. Here, the server owner accesses it, and the blockchain, since the server owner is anyone, because anyone can run a node, anyone can access it. But it's the same problem, fundamental problem. Like, the data in the system cannot be protected from the system itself. And this is what you have to solve for if you want privacy in the blockchain and in the real world. So, summarizing. Privacy can mean essentially two things. Either what you consider should be private or not, so a definition of like a privacy predicate, or an implementation of a private system, which can allow you to extract information or not. Blockchain has a problem not because our idea of privacy is wrong, but because we cannot implement what we want to implement. Web2 is wrong in privacy most of the times, not because there is not the technology for them, but because the concept of privacy is more pervasive and actually allows them to extract information. So there are different problems. You can talk about like, the problem of defining privacy and the problem of implementing privacy. Moreover, all the technology we have today, both in Web3 and Web2, doesn't allow us to protect the information from the system operator. And this is what you're going to have to develop in order to have private Web3 and also to have a lot of different privacy ideas implemented in Web2 in different kinds of systems. Our company is working on such projects, as are many others. In some next videos, we're going to talk about different solutions, different architectures, and some ways in which this can happen. But this is kind of a deeper and technical topic. I'm going to leave it for a different lecture, but there's a whole area of research and companies being built on top of this problem.